So, trick question. Did changing our sample size change our significance level? Does the significance level get affected? No, it doesn't. Look, here we have an alpha of 0.05. Here we have an alpha of 0.05. Here we have an alpha of 0.05. Why? Because the alpha of 0.05 is the area relative to, your H0, right? And it's changing anyway. So proportionally, they stay the same. Now, second question. Does that change our chance of type 1 error? No, it doesn't, because the type 1 error is exactly the 5% that we established in alpha, right? So 5% chance of type 1 error here, 5% chance here, 5% chance here. Okay? Nice. Next question. Does changing our sample size, does that change our chance of type 2 error? Let's look at that. Yes, it does. Why? Because before, we had a 40% chance of type 2 error, right? Letting in drunk people thinking that they're sober. As you increase sample size, this chance of type 2 error decreases to 10% or even to 1% in a very precise sample. Okay, and could decrease forever. So if you ask me, hey Zaki, why would I ever want a big sample size? The answer is, one, you get more precision, and second, you also get less type 2 error, right? So now, we're not going to be letting in drunk people because we think they're sober. We're going to be committing less type 2 errors. All right, less false negatives. Great. On to another trick question. If I change my precision, does that affect my confidence level? No, it doesn't. Why is that? Well, let's say we start with a 95% confidence interval here with a small sample size. What happens when we increase sample size? The 95% stays the same because it's just proportional to the width of the distribution. So that will stay the same. It's like that ruler thing, right? It's the z-score thing. It's always there. And when we change the width of the distribution, the 95 is still there. Do notice that the cut points have changed, right? So 0.1, 0.7, 0.04. Okay, here's another question for you. What if I change my confidence level to 90%? Would that change my precision? Well, it's tricky because let's change this confidence level from 95 to 90%. Okay, you see what happened to the cut points? They did get more precise. So in that sense, your interval is more precise because an interval, numerical interval of minus 0.09 to plus 0.09 is more precise than a numerical interval from minus 0.1 to plus 0.1. Right, of course. So it is more precise in that sense. But it's not it's not precise in the same way that it was before because the standard error is staying the same, right? So look at this. Regardless of what we do here, the standard error, which is just the width of the actual white line distribution, stays the same, okay? Well, before, the standard error changed. So look at this. Before, when we changed, actually, the white curve was actually changing. And that's the cool precision. That's the nice precision. That's the precision that we refer to when we're talking about precision.